Howdy, this is Jim Rutt, and this is The Jim Rutt Show. Listeners have asked us to provide pointers to some of the resources we talk about on the show. We now have links to books and articles referenced in recent podcasts that are available on our website. We also offer full transcripts. Go to jimruttshow.com. That's jimruttshow.com. Today's guest is Antonio Damasio. Antonio is a professor of neuroscience, psychology, and philosophy at the University of Southern California. He's made seminal contributions to the understanding of brain processes underlying emotions, feelings, decision-making, and consciousness. He's published several books on his work, including Descartes' Error, The Feeling of What Happens, Looking for Spinoza, Self Comes to Mind, and The Strange Order of Things. Regular listeners of The Jim Rutt Show know that The Feeling of What Happens is a favorite book of mine and one that I often recommend. Though, as of today, I'll be recommending his new book. Welcome, Antonio.
My pleasure. Good to be here.
Yeah, good to have you. Our chat with Antonio today is part of our ongoing series on the science of consciousness. Previous guests in the series have included Christoph Koch, Bernard Bars, and Emery Brown. Today, we're going to discuss Antonio's newest book, which I think we'll get the episode out on the day the book is published. One of the things that really pisses me off is reading book reviews of books that aren't out yet. So we're going to coordinate with this publisher and get the episode out on the day the book is available. So if you hear this, go get the book. It's called Feeling and Knowing, Making Minds Conscious. Relatively short, quite accessible, and in general, written in a way that I believe would be accessible to a reasonably intelligent layman. So let's hop into it. One of the things that you start the book with, I think is very interesting, is that the idea of intelligence and brain/minds are not inseparable. Even simple organisms like bacteria can exhibit intelligent behavior. Maybe you could explore that distinction a little bit.
Thank you very much for your introduction. As you said, this book is, I hope, quite accessible. It's a different book from my previous books. Since you are acquainted with the others, you know that I write rather long books. And so instead of 400 pages, you have, I think, 240 or something like that. And it was done that way on purpose. And my editor, a marvelous man called Dan Frank at Pantheon, who unfortunately died quite recently of cancer, he wanted me to do this book. And he had been after me for a while saying, you have to write a book that is brief, to the point. You don't need to explain everything. Present your ideas and explain them clearly. And I said, fine, provided I can bring the most complicated and the most up-to-date ideas, I will do that. And so then I started thinking about the book in terms of poetry. And I started thinking in terms of a haiku. And that's sort of what I try to do. A book that is brief and that has many chapters, but the chapters concentrate on one particular aspect and leave out a lot of explanations that would be supporting some of the claims I make, because they can find that in my scientific papers or they can find it in previous books. But the interesting thing is that I'm generally pleased with the way it came out. Of course, as you know, one is never pleased with the work. If one is mildly aware of what is going on, by the time we finish, it's already old and you don't like it. But in general, I like the way the writing came out. What is interesting is that I was able to, since the book was finished on my side and was given to the editor, I've been able to develop a few more facts and present a few more facts in papers that actually go well with the story I'm telling and make it even stronger. So we can talk about that too. But I agree with your description, and let's go back to your first question, which had to do with intelligence and simpler organisms. And I wanted to make sure that people would know that when you take a unicellular organism, even a unicellular organism such as a bacterium, which doesn't even have a nucleus, one cell, no nucleus, but life ticking inside that little body, what you have is an intelligence already, an intelligence at work. And that intelligence is manifest by what that creature does in terms of defending itself from an environment that may be hostile, an environment that may have something that is harmful, such as, for example, high temperature, or not have enough nutrients. And so simple organisms, unicellular or with not many cells, and no nervous system at all, no brain at all, will be able to adjust and put themselves in situations that are most conducive to continuing their life. So the only way of describing this is calling it intelligent behavior, but you have to be very careful and immediately add that this intelligence without consciousness, without knowledge of that intelligence. So these creatures have a covert intelligence, and that intelligence is telling them, quote unquote, to do a certain thing, to adopt a certain position, to have a certain behavior, without the creature having any access to a representation of what the problem is or what the creature is supposed to do. And this is really remarkable, and people ought to know about this so that they don't think that intelligence only comes to creatures like us or only comes to us thanks to the nervous system.
Yeah, in fact, I think you called it implicit intelligence. I thought it was a very good term.
Implicit is a very good name for it. Yeah.
Yes, and then you also make the very interesting point that this implicit intelligence has sort of an implied goal because of the fact that Darwinian evolution of maintaining homeostasis, which turns out to be a pervasive idea in your thinking, might be useful for our audience who are not necessarily specialists in biochemistry to know what homeostasis means in this sense.
Right. So homeostasis is a good synonym for it is rules of life regulation. So basically homeostasis is about a set of goals and regulatory activities that have one purpose and one purpose only, maintaining life for as long as that is possible according to the controls of your genome. So if you are going to maintain your life, or if an organism is going to maintain its life, it has to obey certain rules, it has to do certain things, and it should not do certain other things. For example, in the case of us, it's quite obvious that we need to, for example, drink enough water, eat enough so that we have sources of energy in our organism. We cannot be in an environment that is too hot or too cold. And all of that, writ large, is a way of according to the rules of homeostasis for our particular organism. That's what we need to do. And so it's a very important idea because you cannot conceive of life without having that set of rules. And of course, life would not go on if the organisms were not endowed with that intelligence that you brought up very nicely, and that intelligence is making them obey the rules of homeostasis.
Yeah, in some sense, it's it's the maintenance of the boundary between inside and outside, right?
Exactly. It's making sure that, for example, the outside is not going to destroy your inside. If it does, you're cooked.
Yeah, you still, and this is something we talk about in the show a fair amount, is that membranes need to be semi-permeable, right? They need to be able to get rid of materials they don't want, toxins, side products of chemical reactions, and bring in things they need, such as nutrients and oxygen and things of that sort.
Exactly. Yeah. But it's very interesting because it works for the unicellular organism as much as it works for us. Now, the big difference, of course, is the complexity of simple organism versus our multicellular, multi-system organisms such as we are. And the two very important facts, to make it clear. One, the fact that we are creatures with a nervous system. And two, that nervous system, in our particular case, and in the case of many other complex organisms, has been able to generate something which is called feeling, and which is, for me, the inaugural event of consciousness. So the bacterium that you brought up very nicely does not have to worry about any of this. The bacterium does not have a nervous system, does not have feeling, does not have consciousness and does what it does by virtue of the rules that are implicit in its small organism.
Yeah, on the road to consciousness, you talk about in the book, the next step is minding. I think you called it that, which you described as a series of mental images that relentlessly flow.
Yeah.
Talk about that a little bit. I like the idea, for instance, that you use images in a generic sense, because it doesn't just include visual images. But
that's correct. So, for example, your voice, as it's coming through and as I'm listening to you, your voice is a set of auditory images. And if we were listening to music, there would be a set of auditory images as well. So image is not at all poisoned by the notion of vision, although, of course, we're visual creatures, and vision, for those of us who are sighted, obviously is the dominant kind of image in our minds. But it's very important to think of images as the result. Images are patterns. Again, whether they are auditory or visual or coming from touch, it's still a pattern. And that pattern, in terms of the nervous system, is achieved by creating a map. So what the nervous system is, especially our complex nervous systems, of course, what the nervous systems are good at is generating patterns. And out of those patterns, you create what we call images. And it's very important to bring out because neuroscience has given us enough information to know that this is not just an interesting concept that might or not be true. It is reality. Nervous systems are organized to generate patterns out of the generation of maps. And this, for example, was very nicely proven by the work of brilliant scientists like David Hubel, who clearly mapped out the visual system for us in terms of the activities in visual cortex, the activities in retina, and so forth. So that's when you come to mind is the result of these patterns. And sort of the very beginning of mind is feeling, about which we can talk probably later, depending on how we want to go. But the idea that mind is something independent from consciousness is extremely critical. One of the things, Jim, that I think is most problematic in discussions of the problem of consciousness is that people confuse everything. And so when they're talking about mind, they're talking about sometimes consciousness or vice versa. And this is a problem. If you don't separate mind from consciousness, you don't really have a possibility of explaining what is it that is characteristic of consciousness, what is it that defines it, and what is it that is the problem with understanding consciousness.
Yeah, and if someone who also speaks often on these topics, you can spend a half a day just trying to define what you mean by consciousness. And we'll get to your definition, though. I thought you were quite clever in putting it late in your book. So I think I'll leave it there, and we'll get to it later after we built your model. One of the examples I really like about this idea of mental images and mind, and maybe it has consciousness, maybe not. People argue about it. I think I know where you'll come down, is a frog waiting for a fly. We now know that the frog is not actually waiting for a fly. The frog is waiting for anything that intercepts its field of vision of approximately a certain number of degrees, right? And it doesn't matter if it's a fly or if it's a cork on a fishing rod string, the tongue will reflexively go out and strike it.
Yep.
If it creates this image in the visual cortex of, or the equivalent, I don't know, do frogs have cortexes, but whatever the equivalent visual map is. And so the frog is extracting from the world a pattern. It's writing it into its visual mind. It identifies it as something to flick your tongue at. And it does that, and it may or may not be conscious. Some students of consciousness would say amphibians are not conscious. Some would say they are, but they're right on the line. Unlike mammals and reptiles, which we seem pretty clear about that they're conscious. This one might be mind without conscious, but it does certainly show the extraction of an image from sensory data.
Correct. Yeah. No, they're obviously creatures about which we can be very certain they have the whole range of these complex phenomena. So obviously humans, but if you look, for example, at animals around you, dogs and cats and cows and rabbits, don't have much doubt that they are feeling creatures like we are and conscious creatures like we are. And creatures that are obviously minded like we are, except that their minds have less capacity and less complexity than ours. And that's true for anything other than humans. Humans have an exorbitant mental capacity. We're capable of doing great feats of perception, great feats of recognition. We have great memory banks. We have the possibility of manipulating all those memories in very interesting ways. And that allows us the possibility of reasoning and creating new images and new things. And we have this marvelous thing that is allowing the two of us to converse right now, which is the possibility of translating anything you want in any language you want. So right now, you have your mental images going on. Your thinking process is preparing you and helping you formulate questions for me. And lo and behold, you're translating all of this in the English language. And you could have been typing it for me, but you're actually producing it in oral questions. And guess what? I'm listening to all of those signals, which, by the way, are images just like all the rest. They're patterns. And I'm getting all at those auditory patterns in this case, and I am transforming the auditory patterns into a variety of visual patterns and into arrangements that allow me to get at concepts. And so you and I can understand each other. But the complexity is immense, and you have all of these layers of processing that are at our disposal. And of course, we know that the animals around us don't have all of these devices. They have some. So the dogs and the cats clearly, to me, have feelings. They're conscious. They have visual and auditory perception galore. They have taste and smell, which helps run their lives. But when it comes to creativity, it's fairly limited. They can be, under certain circumstances, if they are part of a breed that is especially smart, they can invent a solution for a little problem, especially a mechanical problem. But of course, their thinking is limited, and they cannot symbolize it. They can create some symbols. For example, when you call a dog with a certain call, the dog will recognize that it's your call and has that capacity. But of course, it's not going to go beyond that, and it's not going to have artistic productions, and it's not going to have intellectual productions in the sense that you and I have done in our careers.
Yeah. Though I do find it interesting that the idea that animals have consciousnesses very much like ours is still controversial.
Yeah.
And not long ago, it was considered absurd.
Absolutely.
People like Descartes said animals are nothing but machinery, right?
Exactly.
And I go, how the hell could somebody think like that? But they do. And a very prominent scientist, I haven't had him on the show yet, but I will at some point, he believes consciousness is only a human artifact.
Yeah.
And it seems very curious.
Very curious. You find things that are totally horrible and sometimes with very little evidence to back it. For example, there's this funny notion that because animals, if you put a mirror in front of an animal, say a dog, there's not much evidence that the dog recognizes its face in the mirror. And so people say, oh, well, if the dog does not recognize the face in the mirror, that's because the dog doesn't have a sense of self. This is completely absurd, because why would the dog recognize its face? And why would the dog's self be based on facial features? Absolutely no reason to do that. Ourselves are not based on our facial features either. Ourselves are based on how we feel about the interior of our organism. And of course, we don't see the interior of our organism in a mirror. That's absolutely silly. And of course, a human baby at 6 months, if you put a mirror in front of the human baby, the baby is not going to react to that face and have a recognition of itself.
And we also know humans that, forager level people live without mirrors, right? Or if you live in a mountainous region, probably there's very little still water. You may have never seen the reflection of your face, and yet you're just as human as you or I, maybe more so, right?
Good. So we are in perfect understanding, Jim.
All right, let's move on to, that was a perfect setup for next step. And this is now getting towards the meat of your thinking. And this is a quote from the book. Any theory that relies exclusively on the nervous system to account for minds and consciousness is also bound to fail. Unfortunately, that is the case with most theories today. The hopeless attempts to explain consciousness exclusively in terms of nervous activity are partly responsible for the idea that consciousness is an inexplicable mystery. And this is where you then get into talking about feelings as you call them the first examples of mind phenomena. And you say it's difficult to exaggerate their significance. So take us on that journey, because this is the heart of the Damasio perspective.
Absolutely. And I think it's interesting because I suspect it's the first time that I wrote a sentence like that, talking about the limitations of just studying the nervous system in order to understand consciousness. And what is very obvious to me is that think about what the beginning of consciousness must have been and what it certainly is even for us today. And you don't need to be a neuroscientist to talk about this. When you think about feelings, what are the feelings that really matter the most and they're most foundational? And I'm going to itemize them for you. Hunger, thirst, pain, well-being, desire. I think that probably would do for the beginning. Why is this so important? It's because these feelings, as they operate for all of us, they are, first of all, conscious naturally. When you have pain, the only reason why pain is going to be useful to you and is going to serve as a signal that something is wrong and that you should look into what is causing that pain to save your life is because it is conscious. So feelings, and these, by the way, I like to call homeostatic feelings to distinguish them from emotional feelings. So, for example, we can all have a feeling of fear or a feeling of joy. Now, that's another story. That comes much later in evolution, and it's a different level of complexity. I'm talking about the feelings that are directly related to the running of this organism and to maintaining its life. Those feelings are giving you immediate knowledge on the basis of which you can act, on the basis of which you can decide what to do. And pain will do that to you, hunger will do that to you, thirst. And of course, if you don't respond to that signal that you're conscious of, something bad is going to happen to you. You're going to get sick and die.
Yeah. And back to our original concept, those basic levels of feelings are essentially signals that you're starting to diverge from homeostasis.
Exactly. Precisely. So it's very interesting because, of course, to begin with, it's very complex, but it's a complexity that is at the bottom of the complexity of our organisms. It's essential. Without that, your life is not going to function. And make sure that your listeners know this. If feelings were not spontaneously, naturally conscious, they wouldn't serve us. They wouldn't be any good and you would die. So when people say, well, consciousness is something that must have come at the end of this long trajectory in evolution, when we come to have big brains, big cerebral cortices, and when we look out at the world and we see all that surrounds us, this is wrong. It's totally wrong. That came later. You cannot understand consciousness by going to the top of the heap. You can understand consciousness by beginning with the beginning, which is the running of life inside an organism. That's the crucial step.
What about the well-known reflex reaction? For instance, you put your finger on a hot stove and you move it away, actually measurably faster than it can enter consciousness.
Well, you're using the same mechanism. That's actually a very interesting point you're making. What you're saying is that you move the finger faster than you could have realized that there was a problem. Yeah, but that's the nature of a reflex. Reflexes they're part of our toolbox, and they allow us to respond actually without consciousness. And that's because of the speed at which the response is necessary. But they are part of their component of the system that ends up producing feeling. So if you go back to the simple organisms prior to having nervous systems, they had already things that were like pre-reflexes. They were not conscious of what was happening, but they could do things to themselves that would move them into the right spot. That's, in a way, you could say that intelligence with which you started your questioning this morning, that intelligence is a reflex intelligence. And we have that possibility of reflex, but we have more. We have the possibility of knowing. And by the way, it's very interesting because where it really gets very complicated is when you have to account for not being in dangerous situations. For example, when you say hunger, thirst, pain, it's obvious that it's protecting you. But what about well-being? Why would you have a feeling of well-being, and why would that be adaptive? Well, well-being is telling you basically, especially it's telling organisms that are complex such as we are, it's time to do other things. You're safe. You're okay for now. So it's time, for example, to have sex and procreate.
Yeah, it's a perfect example. In my own work, I use the white-tailed deer as a model animal. And that's exactly right. That its first priority is eating. Fortunately, deer don't need to drink. They get most of their water from their food. But until their well-being is satisfied, they don't spend time on exploring or sex or fighting or anything else.
Exactly.
But
Yeah.
once they do, then they're able to they get a signal somehow that they have time to go explore, teach their children stuff or what have you. And so that's, that well-being is a seemingly very important signal for even animals seemingly as far down the chain as a white-tailed deer.
Exactly.
Now, another thing that gets so confused, and you use it in a somewhat different way than other people have, is this distinction between emotions and feelings. Some folks, in fact, a lot of the literature I've read on emotions and feelings in the lab psychology world tend to talk about emotions as being the physiological phenomena, your heart's beating and that sort of thing, while the feelings are the mental part. I'm feeling afraid. And in fact, there's this whole argument, what comes first, the feeling of being afraid or the heart beating fast, right? And you use it in a somewhat different way. So why don't you lay out your distinction between emotions and feelings?
Right. So the critical distinction is this. When you talk about feelings, you're talking about events that happen in your mind, and they are through and through subjective. Feeling and subjectivity go hand in hand. So you don't see feelings, you don't hear feelings, you don't watch a feeling. Feelings are in your mind and in my mind. You don't see my feelings and I don't see yours. So this is an entirely mental, internal phenomenon, subjective through and through. And it's actually very nice to use the word subjective because the word subjective has, of course, the root in subject. And that's exactly, the two things go hand in hand. The feeling is responsible for making the subject, and you only have feelings inside the subject. Now, emotions, and actually it's, again, interesting because the root is movement. So when you talk about emotere, what you're talking about is moving towards the outside. Emotions are through and through about movement. Emotions can be seen. If you smile at me, I see that it's an emotive process that you have, and I know from watching the actions in your face that you are possibly in a certain mental state. I don't see the mental state, I don't see your emotive feeling. I see your emotion. So for me, I like to say emotions are theater. Emotions are concerts of actions, and they have predictable patterns. And although, of course, the way you and I express joy or anger or fear is slightly different because our faces are different and our bodies are different. And yet they're so well patterned that everybody recognizes them. And there's the entire acting business in theater and in the movies is based on trying to make the movements that are related to a certain emotion as credible as possible. And that's when we talk about great actors, they're the actors that when they cry or when they express joy or fear, they're believable. Why are they believable? Well, they're believable because they conform to our general pattern of what it is to be in fear or what it is to be angry.
Here's a follow-up question for you that maybe help tease this apart a little bit. As is well known, and you allude to in the book, our episodic memories are tagged with valences of various sorts: good, bad, scary, hopeful, sexy, whatever. Now, are those tags, and again, there's a fair amount of discussion in other works about, are those tags of emotion, or are they tags of feeling? Do they cause the replaying of physiological? Or, what's your view on what is it that is tagged with our episodic memories that's in this feeling/emotion space?
Well, it's mostly feeling. So when you have, for example, you recall a particular event, something has to do with a friend of yours or with your family, and as you recall that event, you may feel sadness or you may feel joy. It's feeling. Feeling is what dominates. What is very curious is that sometimes it spills over. For example, if you are reminiscing, your wife might come into the room, and suppose you were thinking about somebody that you once loved very much and with whom you had a great time. And your wife might come into the room and say, "Why are you smiling?" And it may be that while you were reminiscing about person X, you not only had the feeling of joy and love for that person, but you also spilled it over. And without you having any control of it, your face adopted the mask of happiness. And so that was translated in emotive terms. And what is so important for people to realize is that in a laboratory, you can force to have these phenomena in a particular tank, in a particular cubbyhole. But in reality, these things are extremely fluid and they move from one position to the other. So you may be thinking about a problem, and in the middle of thinking about the problem, you may get to a point in which you don't resolve that particular equation, you don't resolve that particular question you have, and your face may tighten, and you yourself may feel upset by it. Why? Because our minds are extremely permeable, and you don't have a compartment with a little box that is reserved for thinking and a little box that is reserved for feeling. These things are in constant interaction. And that's extremely important to understand, especially when you think about artificial intelligence, which is by definition, not by definition, but is commonly devoid of that aspect of feeling that is so characteristic of living things.
It doesn't have to be, though, as we'll talk about later, right? You lay out a program for it. In fact,
that's right.
My little rudimentary conscious deer has at least the analogs of feelings, and it's quite interesting. I'll give another example, an interesting example when we think about memory, feelings, emotion. PTSD, is an example of a case perhaps where people may have tagged feelings with a memory, but if they retrieve that memory, it also triggers the physiological reaction in a very profound way.
Correct. Yeah. No, and that's, of course, there's a tremendous amount of room in psychopathology. So a lot of the conditions that have traditionally been dealt with in psychiatry can have as a source this permeability of the compartments of our minds and this possibility of getting reactions that are exaggerated or having problems that are exaggerated and that literally spill over into compartments where they shouldn't. Of course, there are many other reasons for mental illness that have nothing to do with this. It can have to do with a genetic disorder, for example. But a lot of them do. And actually, it's curiously because when you think about the history of mental illness, when you think about people like Freud, he was especially concerned with the kinds of conditions that have to do with the permeability of our intellectual and affective compartments. It was that he, in fact, devoted his life to.
Absolutely. We'll get back to talking about that a little bit when we talk about the social cultural aspects of emotions and feelings a little bit later. But back to this, again, this gradual building of your model from streams of imagery to consciousness. You talked about William James and his idea of stream of consciousness, and you basically debunked it and said, it's not exactly consciousness he's talking about. It's a stream of images. And it needs a little bit more than just the images to be conscious. What else does it need?
Well, it needs the feeling. It needs the relationship between the images and your self. And that's what that is why I insist on the idea that to try to understand consciousness by resorting solely to the nervous system is a problem, because if that were the case, we would never have the possibility of feeling deeply about a person, feeling deeply about a problem, having any kind of resonance about what is going on in our lives. That resonance is achieved by the repercussions that our mental events, our mind events have on the living body. And so when a particular image in mind provokes a reaction that is of the emotive kind, and that emotive reaction provokes the consequent feeling, you're just moving very subtly from the world of the nervous system to the world of your body, because you cannot have feelings if you don't have body. What you feel is the result of creating images about the state of your muscles, about the state of your arteries, about the state of your heart and lungs, and a variety of other organs. And all of that under the control of very specific molecules. So again, there's this interplay between what belongs to the nervous system and what belongs to the body. And just one more thing before I quit. Keep in mind that historically, what came first was the body. Nervous systems are not the beginning of life's history. Life begins with living cells, and with more living cells creating tissues, and with organisms accumulating many, many cells organized in different systems. And then, lo and behold, at some point, the confusion is such, the complication is such, that nature came on to selecting one very interesting option, having a kind of cell that can literally, I think you'll like this image, Jim, run herd over the rest. And that is the nervous system. The nervous system is a beautiful afterthought of nature that says, if we're going to create some order in this madhouse, we need to organize and coordinate the function of these different systems. And that's what nervous systems do for us. They coordinate, they organize. And then something that emerged in the middle of that operation of coordination is actually a representation of the state of the organism. And that's what you call feeling. And that representation is about a dialogue between what belongs to the body to begin with and what belongs to the nervous system. But the two are totally together. nervous systems are inside the organism. They don't have to, when you are looking out, I mean, if you look at me, for example, as we're having this conversation, or I look at you on the screen, you're outside of me. There's no way that your image interacts with the molecules in my bloodstream or interacts with the cells that are distributed inside my guts or my heart. So it's a very, very different situation when you look about the outside world. You look at the outside world. When you look into the inside world, what you see is the possibility of one thing being inside the other, namely the nervous system inside the organism, and then, and this is the critical issue, the possibility of dialogue between the nervous system and the rest of the body. And they are in dialogue because one is inside the other, and everything is open for that dialogue to take place.
Yeah, you took a deep dive, which I found very interesting. I learned some things I did not know about what you called the interoception system. And you made various distinctions between these internal systems. As I understood it, the interoception system is the viscera. One could actually say the gut feelings, right? And it's distinct from the skeletal and also the skin sensations, which are all bodily.
Exactly.
But the interoception is one that you point out as fundamental to our state of being. And it makes sense because we think back the history of the neuron. Best I can tell, the neuron came into existence just before the Cambrian explosion and was, is probably essential for those larger body plans that came around in the Cambrian explosion. And, perhaps the first purpose of them was indeed for this interoception monitoring of the body to make sure that, we're coordinating all these damn cells. We better make sure we don't run out of water, for instance. Right?
Exactly. That's very important. And I'm glad you mentioned those separacies. So you have an interoceptive layer, you have a proprioceptive layer, and you have an exteroceptive layer. Okay. First thing to know about these is that they obviously correspond to completely different sectors of our world. The interoceptive corresponds strictly to the insides, literally, to the viscera, to what is going on in the thick of your skin, what is going on in your guts, what's going on inside arteries and arterioles. Okay? The proprioceptive corresponds to a different level. It's connected to movement and corresponds to the striated muscles and to the skeleton. So when you move your biceps, what you're doing is animating a muscular structure which moves a particular part of the body. That's a system that is more modern than the interoceptive. And then you have the exteroceptive, which allows you to taste, smell, touch, hear, and see. And they are in a progression of differentiation, which is absolutely astonishing, because by the time you get to retinal cells, you're dealing with something extremely sophisticated. The cells that you have, for example, the axons that you have in your optic nerve, that is a brilliant achievement of nature. Why? Because you have these absolutely marvelous cables that bring signals with no leakage of current. Now, when you look at the interoceptive system, in keeping with the fact that it is so old and that it was the first system to develop, what you have is a collection of actually primitive neurons. You have neurons and fibers that are very often devoid of myelin. They're not insulated. You have something that I find absolutely astonishing and that people completely ignore. I mention it in the book, and we just have a couple of beautiful papers that were published just in the past couple of months about the fact that there's no blood-brain barrier in ganglia, the spinal ganglia, which are sort of the staging posts to get information from the body into the central nervous system, for example, in the spinal cord or the brainstem.
Yeah, I saw that in that book, and I thought that was quite interesting. I made a note of it, and I said, and maybe it's a way to measure what's going on in the blood, for instance, that the brain can't do.
Of course, that's exactly that. It's a way of communicating. And Jim, the marvelous thing is that it's the body communicating directly to the nervous system and the nervous system responding. This is not a question. One thing that I want readers to understand: this is not about perceiving the body. This is about sensing in the body and in the brain something that is a commingling of both. So when you look outside, when you hear what's going on in the world, you're perceiving the world in the true sense because you are receiving signals from the outside and they're affecting you. When you are looking inside your body, what you have is a combination, a crosstalk between body and nervous system. And that's of a very, very different kind. And I know that you find this interesting.
Indeed. And then, we get to what we're talking about today, which is consciousness. And we again look back at the evolution of nervous systems. Very soon, perception comes in the scene, right? It may not be the full-blown vision we have today, but at least light-sensing cells. And then, or actually even earlier than those, were antennas that give some positional information, some accelerometer type things that provide perception in a sensory modality we don't even really have, which is acceleration. So I would putting words in your mouth, I'll get you a chance to react to them, is that, perhaps what we think of as consciousness happened when the merger between perceptual streams of various sorts, and not necessarily vision, and these internal signals from the interoceptive systems combined into a system that modulated both together.
Yeah, that's a perfectly defensible way of putting it. I think right now I'm being even a little bit more extreme in the sense that I believe that once you have a feeling system, which again I declare the inaugural event in the history of consciousness, once you have feeling, you have created the conditions to build a self, which is really related. The core of the self is your organism ticking away with life. Once you have that, anything that comes into your nervous system, whether it is through vision or hearing, I mean, you hear Mozart's sonata, or you look at the landscape, or you drink a great glass of wine. All of those things are going to become conscious because of the possibility of animating your interoceptive system and creating a feeling. So feeling is not only the inaugural event, it's probably all that you need to have consciousness. And once again, we go back to the beginning of our conversation. People are so used to thinking from the top down, thinking about mind as being conscious, that they don't realize the beauty that it is doing it in the opposite direction. It could not have come from vision. It could not have come from hearing. It had to come from where it did the most good to save a living organism, and that's through feeling.
Yeah, we know, for instance, that you can take the prefrontal cortex out and people remain conscious, right?
Of course. I mean, actually, you can take practically all the cortex out and people remain conscious. I mean, again, the critical events are located at a lower point. And again, that's one of the big problems. First, associating consciousness with the highest grains of perception, say vision or hearing. Wrong, unfortunately wrong. And by the way, anyone, and this includes remarkable people whom I very much admire, some with whom I worked, some who were friends, and when they thought that they were going to get at consciousness through vision, the end result is that they didn't. It's the wrong way to start. So start not from the top, and start not at the level of the cerebral cortex either. There's this very interesting idea that some people have. Say, well, again, we humans have the greatest consciousness possible. For some people, we humans have consciousness and the other creatures don't. And we have this great cerebral cortex, so maybe the two things are together. Well, wrong. You don't start building consciousness from the cerebral cortex. You end up having products of consciousness represented at the level of the cerebral cortex, but that's not where you start. You start inside the organism.
Yeah, it's interesting. And of course, we alluded earlier to the fact that humans are able to have vastly bigger impact on the world and do much more creative things than any other species that we know of, that we don't know what whales are talking about. Maybe they're writing the greatest drama ever written, but at least as far as we know, we're the only ones that have this great creative capability. And if we look at the genetics, we know we're not very different than chimpanzees or bonobos, maybe 1.5%. And we can't see much in the way of the structure of the brain that's radically different. There's a lot more of it. And, perhaps the simplest explanation, a guy I like a lot, Terence Deakins, and his idea that we have a circuit for symbols, perhaps. And, we combine that with Bernard Barr's idea of the global workspace theory and the idea of conscious contents of all sorts, like Nagel and the bat. The bat with echolocation has contents we can't even contemplate what that means, right? And so we may have a special class of conscious content called symbolic. And that may be the only difference or the main difference.
Well, we said arriving at the possibility of symbols has made all the difference. And again, we could not be having this encounter that we're having here if we did not have this amazing symbolic power that comes from language and which allows you to, but it's all about translations. And of course, again, what you need a good cerebral cortex for is to permit the things that we're doing right now. Is this amazing fact that I am trying to translate my thoughts into words in the English language. I'm putting them in sentences. I put that in a system, a vocal system. You're picking that up and you're doing the opposite. You're going from those signals to language, and from the language to expressing through a variety, to a big succession of images. You're expressing something that is equivalent to my ideas. And it really is an amazing process. And that, of course, is what is currently denied to most animals, again, with some of these odd exceptions that we have not explored very well, which may have to do with the signals that animals use in a forest or aquatic animals that use, such as whales. And we don't know enough about that. But even if they may be complex, I doubt that the whales are discussing, Emily Dickinson's poetry.
Yeah, maybe better. Well, we don't know, but probably not. I would agree with you. Now, let's take another cut at this, because again, because our human facility is just so amazing, we get overly fascinated by it, I suspect, when we're talking about consciousness. And as you keep making the point, that's the frosting on the cake. The cake goes way further back. Another definition of consciousness, which you can apply to a dog or a cat or a frog even, is consciousness is when you're not asleep or under deep anesthesia, right? It's the state of being. And you can test that. We had Emery Brown on the show last year, who's a practicing anesthesiologist from one of the big hospitals in Boston. He's also in the Department of Brain and Cognitive Science at MIT. And he's done a lot of work on things that are at least correlates of consciousness and how they come and go with experimentation with anesthesia. And we had a very, very interesting conversation there. But you would suggest that alone is not a sufficient distinction.
Exactly what you mean. I'm sorry if I'm...
Yeah, that you brought up a straw man example of a definition of consciousness, which is the state of not being asleep or under deep anesthesia. And then you teased at how that isn't quite adequate.
Right. Because it doesn't, of course, everything that a person who practices anesthesia daily knows and knows very well, and is correct, is saying that if you put a person under anesthesia, you are obviously going to remove the possibility of consciousness. That's perfectly correct. I don't have any problem with that. That's exactly. And I mentioned anesthesia in certain stages of sleep as very good examples of being in a state of no consciousness. The only thing that is lacking is the detail of how it could have come about and for what. So I have no conflict whatsoever with what anesthesiologists are saying or what people that deal with sleep are saying. That's perfectly fine. The only thing is, so that thing that is removed by anesthesia is what? And it came about through what and for what purpose? And that's where it's not a question of difference. It's a question of adding that component of what it is for and how it comes about. That's the only thing. By the way, one thing that should be noted that has quite a connection with my thinking of consciousness is that why is it that, how many times have you had anesthesia in your life? Probably a few.
Yeah, probably less than 6, but more than 2.
Exactly. Me too. So why is it that we wanted to have anesthesia in the first place?
So you don't be feeling the knife, that's why.
Ah, there you go. So it's very interesting because I've talked to many anesthesiologists and we have conversations and they say, why do you do that? What's the purpose? Because they will say, well, we remove consciousness, we remove all this glitter that we have of our minds. And say, now, wait a minute, the glitter is one thing, but the reason why you're doing it is that when the guy comes with a knife, you don't want to have the pain and the suffering that would cause. And the first thing that anesthesia needs to produce is a reduction of pain. Actually, I wouldn't even mind to be awake, provided I didn't have pain.
I did that. Last time I did a colonoscope, nice topic. They gave me fentanyl of all things, which left me conscious-ish, a little bit befuddled, but no pain. And so there was an example where for a mild procedure, they didn't actually have to disconnect consciousness to pretty much entirely stifle the pain.
Exactly. Yeah. We are in complete agreement.
There was an interesting thing that I did not quite understand, so we can dig into a little bit, is that you talked about anesthesia working as breaking down the sensing capabilities of the organism.
Yeah, it's very radical. So at least the anesthesias I have had, it's very radical. I from 1 second to the other, my consciousness disappeared. I knew nothing. It was not just that I didn't have any pain. I didn't have any pain. I didn't sense anything. Again, as you were saying, you might not have had pain, but be in some kind of cloudy state. I didn't have anything. It was gone. I was a non-person for all intents and purposes. Although, curiously, you maintain your physiology going. It's not completely normal. When people wake up from anesthesia, there are lots of things that are not quite right. Especially if it's very prolonged. I mean, if it's for something like a colonoscopy, fortunately, it's not that long. But if you have big-time surgery that may last 5 hours, when people wake up from anesthesia, it's not just that their consciousness was gone, their physiology was gone too in considerable detail, and nothing seems to work. And of course, it needs to be monitored and maintained. Otherwise, it's not anesthesia. It can be death.
Indeed. Yeah. Emery Brown, he uses propofol, which is a short-acting anesthesia had at one time for a very detailed examination they needed to do internally. So like for half an hour. And what he finds in his work doing EEG while doing anesthesia, and he's a big advocate of combining the two, is that the main effect of propofol, at least, seems to be very high amplitude, slow brain waves that are so powerful they overwhelm the very jittery but low power, much faster gamma frequency, beta frequency, delta frequency, theta frequencies that seem to be at least strongly correlated with our conscious states.
Yeah, that makes perfect sense.
Interesting. Okay. Let's move on here a little bit. I didn't know that you're the one that came up with the idea of extended consciousness. I tend to think of Gerald Edelman, but looks like that was an idea of yours.
Yeah. Although I think Jerry I remember talking about that with him, and I don't think he had any problem with the concept, and he probably had, I can't remember what words he used, but he had things that were equivalent to extended consciousness. Yeah, I don't use the term anymore. It's so interesting in doing science and in thinking about these problems. One problem that is quite critical is the problem of nomenclature. You come up with a certain phenomenon, you describe the phenomenon, and then you want to give it a name so that people can understand what on earth you're talking about. And very often they're names that stay and they no longer satisfy you, or they can be confusing. One of the things that troubles me the most is names that I have used in the past to refer to a particular phenomenon, and I don't like that anymore, and I use slightly different terminology in order to make myself clear. But of course, people may be reading an article from 20 years ago or 30 years ago, and it may be confusing. But it's a problem with the job.
Indeed, especially as our knowledge gets greater as well.
Exactly. Yeah.
Edelman tended to use it in contrast to core consciousness, which he would say things like, all right, core consciousness is the consciousness we share with a dog, being part of our own internal movie, etc. And he used extended consciousness, kind of a hand-wavy way to talk about those things that humans in particular have, and maybe the great apes have a little bit that the other animals don't have, things like, self-consciousness or metacognition, and of course, symbols and language. I thought that was
That's perfectly fine.
Yeah, perfectly interesting. Now, another distinction, we're kind of hitting some interesting side topics here. The distinction between, especially for humans, but probably for mammals as well, distinction between ego and consciousness, right? We know, for instance, that heavy meditators claim, at least, that they can have their egos go away, right? Or heavy doses of psychedelics called so-called ego death. And so one could, in theory, be conscious without a strong sense of ego, and how that might differ from self and your ideas a little bit.
Right. I really don't want to talk much about that because I have not thought about it enough. And I don't think I'm competent enough to discuss it. I'm very intrigued by meditation. And of course, everybody's intrigued by what certain drugs can do. But in both cases, we're talking about states that are outside of the ordinary. And if they were not outside of the ordinary, why would people seek them? People seek meditation because it does something very profound to the way you feel, to the way you gain some wisdom and you gain some peace of mind. And what that means to me is that people are manipulating their feeling systems, and their consciousness, quote unquote, may appear different to them. And that's exactly what they're trying to do. They're trying to alter the typical relationships that we have in our so-called quote unquote normal life. They're trying to alter the balances. And I'm actually very intrigued by meditation. It's not something I practice myself, but what I've tried to do tells me it's very intriguing. And I do know some very serious meditators, and there's no question that they achieve remarkable things about their personas. They are different people as a result of that.
Yeah, I've recently started fooling around with it a little bit and have found some interesting effects. And some of them, though, seem to be on the perceptual side. I did kind of a homebrew deep meditation based on tantric practice of all strange things. And it clearly produced a perceptual change for a few minutes where things became ultra vivid, the salience landscape changed, etc. And so it was much less about feelings and more about changing perceptual weights and salience landscapes, etc.
Interesting. And that was done just with meditation. You were not doing...
Just with meditation, no drugs at all.
No drugs at all.
It was very interesting. What else we want to talk about here? John Searle, one of the people I find is a very interesting talker and thinker about consciousness. While certainly not thinking about consciousness exactly the same as you do, there's an awful lot of similarities in his ideas about the biological grounding of consciousness.
Okay, quite possible. He's a good thinker.
Yeah. He likes to say, in fact, I like to quote him on it, saying that talk about this nomenclature of consciousness and the terminology problem. People want to put their finger on this thing, consciousness, right? As if it were a flashlight battery or something.
Yeah.
And he likes to make the distinction that frankly, consciousness is more of a process kind of like digestion. You can't put a finger on your digestion. It's your tongue, it's your throat, it's your stomach, it's your liver, it's your colon, etc.
Yeah, no, I think there are really so many problems that have made people sort of trip over all of these notions. It's not a little thing that you can point to with your finger, and most importantly, it's not mind alone. And to give people the idea that great minds. So it would mean Shakespeare had a much bigger consciousness than you or I. Well, I don't think so. I think he had the same consciousness that we do, except he was a very bright man and he was capable to work long hours at writing his plays. And he was incredibly brilliant at inventing plots or borrowing plots from the previous dramatists. And he was a great poet, and he could write wonderful lines for his characters. But his consciousness was not bigger just because he wrote 28 plays or something like that. So one thing that your program can do is make clear that people should not confuse consciousness with mind. Mind is one thing, consciousness is another, and clearly our minds, the more educated we are, and also the smarter we are, the greater the capacity of our minds. But that is not going to mean a greater capacity of consciousness. Consciousness is what allows us to know that we're having this great capacity or small capacity or whatever is going on in our minds.
I've got a good follow-up question for that. In cognitive science, there's a tremendous amount of interest these days in attention, and particularly in human subjects, but also to the degree they can do it in non-human subjects. Would you consider attention a phenomena of mind or of consciousness?
Oh, of mind, for sure. But of course, it's a phenomenon that can result in you being or not conscious of a certain thing. So if you are not attentive, you are going to let go certain contents that will never be in your consciousness. So in order for something that is in your mind to be in your consciousness as well, or to be conscious, it depends on how we want to say it, it needs to be taken into account. I mean, attention is about taking something into account. It's about the possibility of processing a certain thing. So if I am very attentive to you, I'm going to be listening carefully to everything you say. I'm going to look at your face. I'm going to try to grasp what you really mean. And that is obviously going to make my mind process sharper. And guess what? If it's sharper, you're going to have a higher likelihood of it producing and being in consciousness, because it's going to produce the respective feeling, or is going to connect with the feeling that allows you to give it the conscious nature. But so attention is on the side of the mind process.
But it sounds like, in your view, it's very close to the boundary. In fact, I sometimes refer to attention as the cursor of consciousness. It's like, because you're plus or minus a few fringe effects, you can only be conscious of one thing at a time. And
I like that.
Your brain is hopping from one thing to the other.
Yeah.
And it's the cursor of consciousness, in that it brings conscious contents into a fully focused state inside a conscious. One of the things we know is that things that you don't attend to are very difficult to, maybe impossible to learn. So learning mechanisms, which may actually be a function of consciousness.
Jimmy, is the cursor of consciousness your idea?
Yes.
Oh, I love that.
Oh, you feel free to use it, right?
Oh, very good. Okay, I like that.
Yeah, I think so. Attention is the cursor of consciousness, because you can see it move from one thing to the other, just like remember, do we even still have cursors? Yeah, I guess we do. We still have cursors on our word processors. In the old days, it was that little underline thing. Now it's the little vertical thing. So let's go to the last topic, and on this we'll exit, which is your thoughts on how machines might be able to be conscious or not, or what the difficulties are, the issues are around the kind of consciousness that you are imagining that consciousness is, and how that might be done or not in artificial machines.
Right. So my thoughts on that are, well, what has always intrigued me is the fact that, of course, machines are very different from living things. They are not vulnerable, they're not perishable, the same way that we are. We are extremely vulnerable. And of course, as we have been describing in this conversation, the response that nature has given to that vulnerability is to invent feelings which protect us from our vulnerabilities by making us aware of certain things that are happening and that need to be corrected, or giving us the opportunity of doing the right thing and exploring the world around. So one thing that occurred to us, and that I mean here, myself and one of my colleagues, Kingston Mann, who was a former student, is the idea that if we could, say in robots, introduce something of our vulnerabilities, for example, by using soft robotics, we might give them a possibility of, quote unquote, thinking differently, precisely because they had those vulnerabilities that were a little bit like ours. Now, the possibility of creating feeling in the proper sense is, of course, quite remote, because to create feeling, we would have to have something that was not just a little bit vulnerable, but could be perishable. That's what our system is. We can live or die. We can get sick, and these machines obviously don't have the materials are very different. But the idea basically is that you, by introducing vulnerability, you could paradoxically increase the intelligence of some of these fabricated organisms, because they might react, they might operate in ways that are more like we poor, vulnerable creatures.
That's very interesting. I've looked a little bit at the so-called OCC model that Clore and some other folks, Ortony, put together, which was specifically designed to be implementable as software, which is a quite complicated, multidimensional, valence-based model of human emotions, or I should say emotions in general. And one could at least contemplate wiring that into AIs. And if you're right, it might be an important part of the road to having real general thinking machines.
See, there you go. There you go. Time will tell.
Time will tell. Well, Antonio, I would like to thank you for a wonderful, deep, and broad conversation. And I would strongly recommend folks pick up your book. Give us the title of the book again.
Okay, here we go. Feeling and Knowing, Making Minds Conscious. And the author of this thing is one Antonio Damasio.
Thank you very much, Antonio, for a fabulous conversation.
Thank you, Jim. It was very nice to talk to you.
Production services and audio editing by Jared Janes Consulting. Music by Tom Muller at modernspacemusic.com.